Hello, hello, hello. It's a great mathematical day in May, right? And we're there. Just wanted to say howdy, get going today. And what are you doing in my house? That's okay. I'm just kidding. We're going to continue on. We're going to get a little bit out of the quadratic formula and a little bit talking about rational and irrational numbers, because you may have noticed working the quadratic formula that sometimes you get a nice rational solution, 7, negative 14. Sometimes you get an irrational solution, 4 plus or minus the square root of 5 divided by 3. You know, that's really wild. So we're just going to talk about rational and irrational numbers today and get started. I do want to mention, wearing something a little different. Don't have my typical wine shirt. In honor of my daughter, I have my Rogers shirt on because this morning the seniors at Rogers High, and she is graduating this year, got to go up there, do a drive-through parking lot, drop off all your books and all your Chromebooks and stuff, pick up your cap and gown, announcements, get your yearbook, all that good stuff. So we did that this morning. So honor her today. I'm wearing my shirt all day, just show a little excitement for her. So she's pretty tickled. We're tickled. This is our last one. Last one's graduating. It's gonna get weird around here. No kids in high school anymore. So, but I got you guys. So let's do this. Let's switch over here. Hey, there we go. Now we're looking good. All right, so we're going to talk about rational and irrational solutions. So numbers like negative 1.7, square root of 16, and 5/3 are rational numbers. Rational numbers. Highlight rational. These are rational. These are the numbers we're used to dealing. And you look at that and you're like, what do you mean square root of 16 is a rational number? Because if you simplify that, what is the square root of 16? It's 4 or negative 4, right? That's a number. So that's something commonly used to 4 and negative 4. Either one of those with the square root of 16. Those are just rational numbers. 5/3, rational number. How would we define a rational number? A rational number is, of course, all whole numbers. Any decimals that are terminating or that repeat. 0.33333, because you can write those as a fraction using whole numbers. So anything we can write as a fraction, because this is 5/3. If we wrote that as a decimal, it's 1.666666 repeating. So the repeating decimals and the terminating decimal, 0.7, are rational numbers. Numbers like the square root of 12, that's not a whole number. That is a decimal. It doesn't repeat and it keeps going. We have to round it if we write it as a decimal. And the square root of 5/9 are irrational numbers. And square root of 5/9, let's talk about that one. When you have the square root of a fraction, you can rewrite that as the square root of 5 over the square root of 9. That's the same number. And the square root of 9, we know, simplifies to be 3. So this is really a square root of 5 over the whole number 3. But still, that square root of 5 makes that an irrational number because that's not a nice terminating decimal. It's a decimal that keeps going. We have to round it off. So when you think about other irrational numbers, pi, right? 3.140159. It keeps going. It does not repeat. It's not a decimal. It repeats. So there are certain numbers like that pi would be an irrational number. So anytime you see one of these, square root of 12, square root of 5, square root of 7, something like that, that is not a nice 3 decimal number, like, you know, some numbers is just like 1/8 is like 0.125, and it ends right there, 0.125. So that is a rational number. So that's kind of the difference, rational, irrational. So let's look at this nice big definition I found. So we're going to use this. Real numbers, rational numbers, all integers, just our normal counting numbers like that. Finite decimals, finite means it ends. There's an ending point, the decimal. And recurring decimals, like we talked about, negative 2, negative 1, 0, 1, 2, 3.25, 1.153, and it ends there. It's not rounded. And it continues on like that. 2.1111111111 repeating. 3.121212, even the repeating. So, you know, there's some fractions that gets to the 41st decimal and starts repeating. So some of those can kind of fool you. But generally you can see a repeating pattern pretty early. Those are all rational. Irrational numbers. Pi, E. Yes, E is also a number in math. Get to that in another class. Square root of 2, square root of 3, those type of things that do not simplify to an integer. So a lot of these are irrational numbers. So they gave us a list at the bottom, and they want us to sort them into rational, irrational. All right, can we do that? Take a look at that. See if you can get ahead of me on that. 97, rational, right? That's a rational number. Negative 8.2 terminates right there, 0.2, rational number. Square root of 5. Square root of 5 is irrational. We're going to put an I into that for irrational. Negative 3/7. Negative 3/7, we can write that as a fraction using integers. That is a rational number. Square root of 100. Well, if you simplify that, that's just 10. Plus or minus 10, either one of those. But those are rational numbers, so that is a rational number. Square root of 9/4. You're like, oh, that's gonna be well. Remember, we can rewrite that as the square root of 9 over the square root of 4, which simplifies. Square root of 9 is 3. Square root of 4 is 2. That's just 3 halves. 3 halves is the square root of 9/4. Just 3 halves times 3 halves is 9/4. That is a rational number because that's a rational number. Negative the square root of 18. We can have negative the square root of 18 as long as the negative is outside, right? If it's the square root of negative 18, we got to have a whole higher math course before we can ever talk about defining that, because in Algebra 1, the square root of negative 18 does not exist. But negative square root of 18, square root of 18 is an irrational number because it's going to be one of those decimals that goes on, and then we would have to round. So we have 2 irrational numbers in this sequence. The rest are all rational numbers. So we needed to talk about that. Let's continue on looking at some in comparison to our quadratic equations. So suspected irrational solutions, right? We talked about getting those with our quadratic formula. This says graph each one using graphing technology. So we'll do that on our computer. Identify the zeros of the function, the solutions. What would x equal to make those equal to 0? And say whether you think it might be rational or irrational. Be prepared to explain your reasoning. So let's look at these. I have these 4. We're going to write down the zeros. We're going to write down whether we think they're rational or irrational. Then we'll figure that out. Let me switch over here to take a look at our equation. So here is the equations over here. I've got them all written down. Oh, I don't need pluses over there. Okay, here is our 4 equations. Let's look at the first one. Okay, here is y equals x squared minus 8. What are the zeros? Well, let's see. If I click on that, it'll leave it up there for me. Right there with 0. So it is negative 2.828. Don't quite have enough information to know. Is that repeating? It might be. Let me write the zeros down on our sheet. We'll get back to it. The negative 2.828 and positive 2.828. Those are the zeros. That's where y equals 0 at. So right now, looks like it's probably rounded, but we don't know if it's repeating. Let's guess and say maybe that's repeating. I see 2828, even though one of them's in front of the decimal. Let's just guess that might be rational. I'm gonna put rational with a question mark. All right, let's look at the next one. So let's switch. This is the second, x minus 5 squared minus 1. So let's move over here, zoom in a little bit, and let's look at the zeros of this one. So if we go here, the 0 is 4, and the 0 is 6. Hey, those we know right off. Are they rational or irrational? Obviously, those are integers, so those are definitely rational. I'm going to put an exclamation point. Rational. That one's not very hard to figure out. Rational numbers. All right, let's look at our next one. We have y equals x minus 7 squared minus 2. Okay, let's see our first one. 5.586 and 8.414. 5.586, 8.414. That kind of looks like it might be a non-repeating decimal that's been rounded to that, because it's only showing us 3 digits. Let's guess irrational. Like I said, we'll go back and figure out if we're right or not. But just look at that. I think maybe this one's repeating the 414. Maybe it's 4141414, but the other one not necessarily. So that would mean we have irrational solutions. Let's try this next one. X divided by 4 squared minus 5. What's that look like? Ooh, well, divided by 4 makes this in a really wide quadratic. See when the graph that? The x is divided, so it's 1/4 x basically. Same thing as 1/4 x. So with x being less than 1, that widens our quadratic. We looked at that way back in the first quarter of the year, I believe. So here's 1, 0. Ooh, negative 8.944 and positive 8.944. So plus or minus 8.944 kind of looks irrational, like maybe that's a rounded decimal. We're gonna guess on that. All right, so there are, here we'll put them all in there. There's the 4 equations we looked at. All right, so there are all 4 of them at the same time, and we have a mixture of stuff there. So let's see where to go from here. Okay. How about that? Rational, maybe? That's just guessing that that's repeating. That one's definitely rational. And then I'm going to guess these are irrational. Let's find out. We don't know at this point necessarily. We just suspect that we might have some irrational ones. Okay. Here are the same equations. It wants us to find the exact solution, not approximate. That means we're not going to graph this. We've got to do the math to find out exactly what it equals. So, show our reason. Whether we think it's rational or irrational. Prepared to explain our reasoning. We could do this. All right, so x squared minus 8 equals 0. So if we add 8, that gives us the equation x squared equals 8. Okay, so we take the square root of both sides to get the answer of x. Since the square root of x squared is x, our answer is x is the square root of 8 plus or minus. Plus or minus the square root of 8. And that looks to be irrational. Square root of 8. It's not a number that comes to an integer. I'm going to say that is irrational. That's one that we had guessed. Maybe that's a repeating one. But it doesn't look like it. It looks like it's going to be an irrational solution. This one, x minus 5 squared equals 1. This is already simplified down to 1 squared. So if we take the square root, x minus 5 will equal, what is the square root of 1? Plus or minus 1. Either one of those will multiply to 1. So either x minus 5 equals 1, or x minus 5 equals negative 1. Add 5. Add 5. So either x equals 6 or x equals 4. We knew that one. That was the one graph we had that was whole numbers. So we knew that was rational. We had an exclamation mark after that one. Let's look at this. Same as this, we're already down to just one expression squared. So that means x minus 7 either equals 2. Oh, I'm sorry. Yeah, the square root of 2. Because square root of 2 times the square root of 2 would be 2. So we're having to take the square root of both sides. Or x minus 7 equals negative square root of 2. One of those. Add 7 to both sides. So x equals 7 plus the square root of 2, or x equals 7 minus the square root of 2. It's got a rational component with the 7, but the square root of 2, when we add that to the 7, square root of 2 is not a rational number. That's irrational. So this is an irrational solution because we're adding it to the 7. Which means now it's 8 point something, 8.41, and just the decimal continues. It's not a repeating decimal. So this is irrational. 7 plus square root of 2, 7 minus square root of 2. Let's look at this one. We're going to have to move the 5. So x over 4 squared equals 5. Okay, so that means x divided by 4 equals 5, square root of 5, because square root of both sides, or x divided by 4 equals negative square root of 5. One or the other. So to get x by itself here, see up here we had like x minus 7 or x minus 5. We had to add 5. This one we got to multiply by 4. So when we multiply, that's 4, and this is 4 times the square root of 5. We can't simplify that. Square root of 5 is a decimal that goes on and on, but we can multiply it by 4 that way. Over here, we've got to do the same thing. We'll multiply it by 4. It's negative 4 square roots of 5, or 4 times the negative square root of 5. We can put the negative out front. So it's a 4 square roots of 5 or negative 4 square roots of 5. Either way, that's an irrational solution. So turns out only our integers were rational solutions on this. The rest of it appears to be irrational square roots of 2, square roots of different odd numbers that work out that way. We can, if we want to double check that, the square root of 8 is the same thing as the square root of 4 times the square root of 2. Same thing when you multiply two irrational numbers, two square roots like that, you just multiply the numbers underneath it, leave it underneath there. The square root of 4 is 2, but the square root of 2 is an irrational number. So it's the same as plus or minus 2 square roots of 2, which means it is irrational because we know the square root of 2 is not a rational number. So this is the same thing simplified, simplifying the radical, 2 square roots of 2. So we had 3 irrational solutions, 1 rational solution in all of that. But that's okay. That's what we're looking at. Let's experiment with rational and irrational numbers. Here's a list of numbers. So they gave us some numbers here. And if you'll look at them, 2, 3, 1/3, and 0, these first 4, they're all rational numbers. The second 4, square root of 2, square root of 3, negative the square root of 3, and 1 divided by the square root of 3, these 4 are all irrational numbers. So they gave us 4 of each. So here's some statements about the sums and products. Sums is when we add 2 things, we get a sum. Products is when we multiply. So we multiply 2 things together, we get a product. For each statement, decide whether it's always true, true for some numbers but not others, or never true. So it's either true, sometimes true, or never true. And that's what we're really trying to decide. So let's experiment with the numbers given. We're supposed to use the numbers they gave us. That's why they gave us these. So the sum of 2 rational numbers is rational. 2 rational numbers. So picking these first 4, if we add any 2 of those together, 2 plus 3, 2 plus a third, 2 plus 0, 3 plus a third. If we add any of those together, we're still going to get a rational number every time, right? Every time. So that is always. Always. Yeah, if we add 2 numbers together rational, we're always going to get one a result of the sum that will be rational. The sum of a rational number and an irrational number is irrational. So if we add 2 plus the square root of 2, yeah, that's not a rational number because the square root of 2 that we're adding to it is a decimal that does not repeat, does not terminate. 2 plus the square root of 3, 2 minus the square root of 3, or plus the negative square root of 3. 2 plus 1 divided by the square root of 3. How about 1/3 plus 1 divided by the square root of 3? How about 0 plus the square root of 3? Any time we're adding one of these to one of these, it's just always turning out to be an irrational number. So that is always true. How about if we add 2 irrational numbers together? Is that irrational? Square root of 2 plus the square root of 3. 2 different decimals that just go on, and we're going to add them together. Yeah, that's still going to be an irrational number, square root of 2. Square root of 2 added to the negative square root of 3. So it'd be square root of 2 minus the square root of 3. Yeah, that's an irrational number. 2 plus 1 divided by the square root of 3. Yeah, that's going to be an irrational number. So it's looking like it's always. Except for, let's look at the next pair. How about if we add 3 minus the square root of 3? Oh, 3 minus the square root of 3. Oh, the square root of 3 minus the square root of 3 is 0, which is a rational number. it put us in the other column. So this is sometimes true. In fact, it's probably most of the times true, right? Most of the time. But there are circumstances that we could end up with a rational number when we add two irrational numbers together. So, not always true. Not always true. Interesting. Let's try this. The product of two rational numbers is rational. So if we multiply two of these together, 2 times 3, 2 times 1/3, which is 2/3, 2 times 0, 0. If we multiply 0 by any rational number, it's going to be 0. 2 times 3, 3 times a third, 3 times a third is 1. That's a rational. So the product is always rational. Always. Can't find a case where it's not. How about the product of a rational and irrational number? Oh, well, that's interesting. Let's see that. 2 times the square root of 2. Well, that's 2 square roots of 2. That's still irrational. 2 times the square root of 3. That's 2 times the negative square root of 3. 2 times 1 divided by square root of 3. That would be 2 divided by square root of 3. Yeah, that's still going to be an irrational number. In fact, let me see if I can't find us a nice illustration of that online. We'll switch over real quick. Okay, let's look at this. If we take the square root of 2, let's get what the answer is. Oh, wait, it was going to show me it before that. I messed that up. Clear all. Square root of 2. It's 1.414213560. It's not repeating. And if we multiply that by 2, which is what we were looking at, by a rational number. Oh, it put it inside there. Need to pull it outside. All right, we'll click outside. Times 2. Now it's 2.82842712. Still, it's not a repeating decimal. If we multiply it by 3, 4.242640687. Doesn't seem to be changing there. Product of rational and irrational. Let's go to the square root of 3. And let's multiply that times 3. Oh, 5.1961524. It's still, even though we took the 3 and the square root of 3, that's not working. Wait a minute, I think we have one more combination. How about if we had a rational number of 0? It equals 0. So, if we look at this, when we multiply any of these that we have times any of these, we still get an irrational number. But this rational number of 0 will make all of those 0. So that's another one that sometimes it's a rational number. Sometimes. Not often, perhaps, but sometimes. The product of two irrational numbers is irrational. Oh, that's a good one to look at. So let's go back and look at our calculator here. So what if we took the square root of 3, which we see is 1.7320508808, and we multiply that times the square root of 2. 2.44948897. It's still irrational, isn't it? Let's multiply it by the negative square root of 3. How about that? Negative square root of 3. Negative 3. Ah, there we go. So if we multiply it together by itself, how about the square root of 3 times the square root of 3? That's 3. I wonder about the 1 divided by. Let's put parentheses, the 1 divided by the square root of 3. Square root of 3. And let's cancel this one out here. 1 divided by square root of 3. That equals 1. Square root of 3 times 1 over the square root of 3 equals 1. But if I multiplied it by the square root of 2, oh, that's not what I wanted. 2, it's, there we go. square root of 2 times 1 over square root of 3. Then I ended up with an irrational again. So this is another one of those that we're looking at that is a sometimes, because sometimes we got -3. If we took square root of 3 times square root of 3, we get positive 3. If we took square root of 3 times 1 divided by square root of 3, we got 1. So sometimes the product of two irrational numbers can be rational. Sometimes it's irrational. So this is a sometimes. This is a sometimes. Always, sometimes, always, always. So there. 3 out of the 6 were always. 3 out of the 6 were sometimes. None of those are never. Those are never. The only thing that would be never if we said the product of two rational numbers is irrational. Well, that'd be never because it's always rational. So, different things. Looking at rational, irrational. That's as much as we're going to do today. We're going to cut it off right there. Have assignments dealing with some rational and irrational. So if you forget any of that, you need to come back and brush up a little bit on here when you're working on that. Get that done. But anyway, we will see you next time.